Hi, my name is Utpal Anurag and this is experiment 4 video. So first we proceed, this is my ID and now we come back at the topic. In this experiment we are going to configure the IC 74LS163N to count from 0 to 15 and count back from 15 to 0 in the binary mode. So let's look at all the component that we required for this. So first thing that we required is our IC74LS163N for counting the binaries, and now the second component that we required is our 555 timer IC to give a clock pulse of 1 Hz to our counter. And the third component is our ADLM kit. We are using it for giving the power source to circuit. And the last, we need some resistor of 100k, two resistor of 100k and a capacitor of a 4.7 microfarad to generate a square wave of 1 Hz from the 555 IC. So now I have made the circuit of the counter and both counter and our 555 IC, but we go through the dataset of each IC. So first we go through the dataset of our counter. So there are 16 pins here, 8 on the left side, 8 on the right side of this IC. So there is a notch at the top of this IC in the left side. So that is our pin 1. We count it as pin 1, and from there there is pin 2, 3, 4, 5, 6, 7 and 8. Similarly on the right side there are 8 pins. So the first pin is pin 1 is our CLR, which clears the output, and we connected it to the high. Now the second pin is our clock input pin. So we are giving the clock from 555 timer IC to this via pin 2. So now, pin 3 to 6 are our input pins, and pin 7 is our ENP, which is also connected to the high, and pin 8 is our ground, which is connected to the low. Low means ground. For convention we have also used red wire as high, means VCC, and that black wire for our low, means ground. Pin 9 is connected to our VCC, means high, it is also our load. And now the pin 16 is our VCC, so it is so obvious that it's connected to our red wire, means it is connected to VCC. Now our output pins are from pin 11 to 14. We have connected our LEDs there to count it in the binary form. When LED glows, it goes high, it means we can consider it as a 1, and when LED goes off, we consider it as a 0. We see our 555 timer IC pin configuration and how we have made the connection. So the first pin is our pin 1, which is connected to the ground, which is also the ground pin, and second pin is getting it input from the pin 6. And now the pin 3 is our output pin, which we generate 1 Hz frequency square wave and give it to the counter. Now the pin 4 is also connected to the high, and pin 8 is connected to the VCC, and pin 7 is connected to the junction of the two resistor of 100k, and which are connected in the series, like 100k and one capacitor of 4.7 microfarad are connected in the series. So the junction between the R1 and R2 is going to the pin 7, and similarly the junction between the R2 and the capacitor goes to pin 6, and pin 6 is also going to our pin 2, and pin 5 we have connected with this capacitor by using this capacitor to reduce any noise in the circuit. We are going to power up our circuit. So this gray wire which we are giving to the VCC, and this blue wire to our ground. So it start counting now. We can see it is counting from 00 to 15. We can also connect one LED between this pin 3 of our timer IC to see the clock speed. So it is running on 1 Hz, and now it is counting from 00 to 15 in the binary form. We have given our power to this circuit, and we can see that clock is also running. It is a blue one. The clock is giving the blue LED light with frequency of 1 Hz, and our counter also glowing the LEDs as in the binary form from 0 to 15. This is demonstration of our week 4 experiment, in which we have to count from 0 to 15 from our counter by using the LEDs. So now, thank you.